Our last speaker is Dr. Shyam Sablani, who is a professor of food engineering at Washington State University. His research focuses on developing sustainable polymer packaging and advancing food manufacturing technology to improve food safety and quality. He is an IoT fellow and also the editor of Journal of Food Engineering. He's a co-organizer of Conference of Food Engineering 2024 and 2026. Okay.
Good afternoon. Thank you, Zhu, and thank you, Elias, for inviting me here. There's been a lot of learning. I'm amazed to see how AI is being used for product development, molecular understanding, health, nutrition, many different fields. So we are also trying to see the application of AI in efficient food supply chain management. With me, my colleague at Washington State University, Dr. Kang Huang, who does a little bit of AI. And we are also collaborating with Jiming Tang at University of Washington to really for the cloud computing to host these models on the cloud so that we can have real-time access to these models. And Washington Tree Fruit Commission, as well as some other food growers and packers from Washington State, they are collaborating with on this project. So as we know, supply chain plays a vital role in delivering foods. Whatever you develop, process, and then eventually, supply chain helps us to deliver at the right place. But supply chain also increases the risk of food losses, especially for fresh produce, as well as some other temperature-sensitive products, because there could be a break in supply cold chain. There could be possibility of temperature abuse within the supply chain, which can affect the shelf life and sometimes safety of the product. So we are looking into digital twin as strategy for reducing the post-harvest losses. So digital twin basically replicates supply chain, and what we hope to monitor the product flow along the supply chain, monitor the food condition, and analyze those conditions, and based on that, we predict the shelf life, remaining shelf life. And what we want to use the mobile sensors, Internet of Things, and wireless connectivity to transmit these data collected in real time during the supply chain, send it to the cloud, and on the cloud we have the machine learning based models which can predict the quality or the remaining shelf life of the product, and that can help managers who are monitoring the supply chain for the inventory management. For example, if there's a shipping going from California to New York, and in between there is a breakdown in refrigeration unit in the truck, and now product is exposed to higher temperature, now the product may not have the same shelf life, okay? And if it is shelf life is reduced dramatically, then people who are managing this inventory, they can make a decision that rather than shipping complete to the New York, they say unload here and try to sell the product in between. Yeah, overall monitoring this product from one end to another end can also help the traceability framework, because you're continuously getting the information from the supply chain. So this is the framework which we are working for this fresh produce, but also this could be used for the other temperature sensitive products, such as pasteurized product, fruits and juices, meat, as well as the frozen product, where there is a possibility of temperature abuse. So within the supply chain, from production to consumer, but we particularly want to work from production up to the retail, not the consumer side. And we are utilizing a lot of sensors which are already available commercially, temperature, relative humidity, vibration sensors are also becoming now available in the market, gas analysis, as well as the imaging. So we particularly at this time are focusing on temperature, relative humidity, and the imaging. And of course, there are a lot of technologies available, devices which can communicate the mobile sensor data to the cloud, any storage platform. And for storage, there are different, technologies are available, platforms are available, and we are interested in using cloud. So we collect the mobile sensor data to the communication technology devices, transfer it to the cloud, and where we can host the machine learning models to further visualize the data, analyze the data, and do some shelf life prediction. And this we could do on laptop, computer, desktop, as well as the smartphones. So one of the things especially with the fruits, we cannot embed the sensors within the fruit itself because it will be destructive, and we may have some other challenges with it. So what we are thinking, rather than embedding the sensor into a real fruit, we simulate the fruit. So using 3D printing, we can print the fruit, especially the outer shell, but we need to match the other fruit properties, such as physical properties, density, porosity, thermal properties, so that it can respond, especially to heat transfer conditions, as the real fruit will behave. And also, we could also simulate the transpiration property. We can make that laser drill holes on the surface, so that if there is any weight loss due to the lower relative humidity around, so that it can transpire that water from inside. And the idea is that we can retrieve these biophysical models, and after the shipment is complete, we can retrieve back and we can reuse them. And in order to simulate the properties, we can fill this 3D printed model with some biopolymer gel and the polystyrene beads. We can change the composition, concentration, to simulate very similar physical property like the real fruit. And once we have this real fruit with the appropriate physical properties, then we can embed some of the sensors. It could be thermocouple, it could be wireless temperature loggers. So far we have not found the wireless temperature logger which can transmit the data in a real time. Some industry companies are using this to collect the data and analyze after the shipment is complete. But at this moment, we are thinking of using thermocouple wires and which are connected to the controllers, and these controllers can eventually transmit the data to the cloud. And parallelly, we are developing the food quality degradation models, again using the AI platform. So we have the initial conditions of the fruit, and they are subjected to different time, temperature, and relative humidity combination. And we look at the quality in terms of the bacterial growth, color, using the image, texture, firmness, and the weight loss. And using machine learning models, we train these models, and then we host them on cloud platform. And of course, once we have that data transmitted through the mobile sensor, through 4G mobile or any other transmitting devices, they will be also transferred to the cloud, and we have the machine learning models for shelf life estimation also on the cloud. And then we can do this all computation in the real time. So this will give an opportunity to the inventory control for the managers who are managing these inventory and monitoring the shipment, that what is the remaining life of the shelf, what is the remaining shelf life of this product as product is being shipped from location A to location B. Not only that, once we learn that how these shipping conditions or the transport conditions are influencing the shelf life, we can use this modeling approach to optimize even the shipping condition. For example, we know that there is a possibility of temperature abuse along the line. So how can we change the refrigeration condition within the truck to even minimize the impact of if there is a chance of the temperature abuse. The main role of AI would come even further once we have, for example, this platform is being used by Amazon or Walmart, who are heavily involved in supply chain. They collect the historical data from these sensors. And then later, we can also collect the transactional data. For example, product specification, from which farm they were produced, given fruit, what was the variety, what was the initial conditions, what was the maturity level. We also collect the data, the transport line, like what was the shipping route, you know, if it's going point A to point B, what was the shipping route? Many times the shipment does not go from point A to point B. In between, half the truck is unloaded, then they are combined with the other shipment. It could happen multiple places, the docking and cross-docking. So if we collect that information as well, we can have also the technical information about the refrigeration unit on those trucks, whether they are using their own trucks, how old it is, or if they are renting those trucks, refrigerated trucks, you know, how old the refrigeration units are there on those. So we collect that information. We can also have the truck driver identity information, or which year of the, you know, part of the year this shipment is taking place, and what was the weather condition. All that, when we collect this transactional data and combine with the historical data of this mobile sensor, then we will be able to predict, you know, what would happen to this supply chain. And once the managers who are monitoring the supply chain, they will be able to, you know, find the solution. If this could happen, then this could be the solution. So this will provide an opportunity to improve the resilience of the supply chain. That's what we are working on. Thank you.